Hello everyone, my name is Jim Lewis. I'm the founder of Model Train Technology. We're a new company and we're focused on lighting and animation and sound. And today is a virtual workshop where we're going to be highlighting two groups of products that we make. One is light boards for passenger cars and cabooses, and we'll show you how we do that. And then the second section is our lighting controllers for buildings and the layout. And included in that are our new fiber optic control lighting systems. As well, we'll show you some new products at the end, including our multicolored block signals that are lit and controlled by fiber optic lighting. It makes everything a whole lot easier. This is going to be a whirlwind, and it takes about 40 minutes for the two sections. And then we'd happy to hear from you. If you'd like to reach us directly, my email is jim@modeltrainman.com or jim@modeltraintechnology.com. Both will get you to me. And our website is modeltraintechnology.com. If you forget all of that, you can go to your browser tomorrow morning or whatever and type Model Train Lighting and Animation. And pretty sure you're going to see us listed in the top 4 or 5 companies on Google. So that's a really easy way. You don't even have to write anything down. Really appreciate hearing from you, and we're excited to share with you what we've invented over the last 18 months. Thanks for watching. Okay, for the first part of this presentation, we're going to be talking about light boards to light passenger cars and cabooses. And this is where it all started. I had an N-scale Amtrak. These two are made by Kato, and I wanted to light this car. I had a whole train, 11 passenger cars, and there was no lights in them. I mean, Kato has some cheap single LED and plastic light pipes, but they don't work very well. So I took the car apart and I bought a Digitrax 4-function decoder, hacked out the seats, put some LEDs in there, and I got it to work, but it was a lot of work and it destroyed the inside of the car. So I said to myself, somebody must have designed and built a board that will slip right inside there. And well, you know the story, there wasn't. So this is now the 12th generation of the LED light board. This has a full DCC compliant decoder on it. It works like an engine decoder called a multifunction decoder. This one has, excuse me, all of the banks of capacitors, which we've now been able to add on. This is a new technology. These tantalum capacitors are very small and compact and very efficient. And there's some other features on the board that we'll go through in just a minute. But that fits perfectly inside the roof and inside the plastic tabs, actually would go that way, inside the Kato car. And of course the Kato have wheel pickups on both trucks. So this works great. And usually for the Kato, we recommend that you use one extra bank of capacitors. So you can buy the board with 1 capacitor, 4 capacitors, or 7 capacitors. And if you're going to use our brass pickups, which we'll talk about in just a minute, we suggest you put all the capacitors on there and go that way. The board, all of the LEDs are mounted on the board. You can't cut this, it's just one piece. If you have a smaller, some of the European cars require a shorter board. We have a shorter version of that. This is 124 millimeters, this is 144. And all of these LEDs come in 4 colors. So when you order the board, you can choose 2000K, which is a kind of yellowish candle color. We use that often for the cabooses. 3000K, 5000, and 6500. And the difference is 5000 and the 6500K tend to be a much brighter sort of fluorescent bluish color. This car has the 3000 in it. And I'm going to turn on the lights over here. And the functions of this, you can adjust the brightness remotely. I'm using a Digitrax system today. There are 2 circuits on the board, one for the main LED lights in the board, and then an auxiliary pad so you can attach LEDs and marker lights. Now what we usually do is we take a pre-wired 0402 LED and dip it in something called gallery glass. It dries crystal clear. It's a little bit soft, but it works perfectly in terms of inserting it back inside the car. And the beauty is as you use it as a kind of glue, it is removable. So if you make a mistake or you need to make a change, or if the LED burns out, which is pretty rare, but if you had to do that, you can change it. So we don't recommend you use super glue or anything like that. All right. Now, that works great if you have a Kato car, but if you have another brand that doesn't have the wheel pickups, and some of the other cars did, then what do you do? So I'm going to use this HO board car, and I'm going to show you exactly what we did. We have something called floating brass. And what we do is, so I wanted to be designing circuit boards. I didn't want to be spending time figuring out this brass strip capability. But I tried everything and it didn't really work. And so we came up with this idea that if you soldered a piece of wire to a brass strip and then slid it underneath the axles, just like this, and then just wrapped it around the axles, it produced, it caused a lot of surface area contact between the axle and the brass, which is good. And also, kind of by trial and error, we discovered that by not gluing it and fastening it to the truck and let it float, it avoided one of the key problems of all of those systems, is pinching the axles. And that, of course, creates a lot of friction on the car, and that's bad. So this has worked really well for us, and it's easy to install. We get these brass strips, we have them custom etched in Scotland, and this is what it looks like when it comes to you, and you can just use a regular pair of scissors to cut it up and stick it in. This is the N size. There are 7 strips, and on the HO it's 2 millimeters wide, so there are 5 strips on there. I think these are $5. So we're not trying to make money on this, just make it available to you. And so let's take the car apart. I left this loose, as you saw. And inside, this is our HO board. And this has, you can order up to 12 of the super caps. On the HO boards, we have a switching power supply. Now, what that means is that the current coming from the tracks is about 14, just under 14 volts typically. The LEDs and the CPU on here for the decoder only need 5 volts. So the difference has to go somewhere, and typically that goes in the form of heat. Well, we didn't want any heat in the board, and we didn't want to use extra current from the tracks that takes away from the engine to light the cars. So what the switching power supply does is uses a high frequency switching mechanism to only use as much current as the circuit board needs. So if you have a normally set LED brightness, very, very little current comes and is drawn into the track. So that really helps quite a lot. Other things that we did on the board is there's a blue light on here that you can disable. There's a little solder pad. So when we're assembling this and we want to make sure that the board contact with the track and everything is working, when we put it on the track, you can see that there's a blue light. So once we've got the install working and everything, then we can disable that and put the top on. Likewise, there's an LED in the back for a red light to connect for the rears, just to make sure that's working. And we use double stick tape to fasten it in. All right. The last thing that we did, which is a fairly new part, is I was taking these apart and I forgot, I'm doing installations for customers, and I would forget the address. And so I'd have to disconnect and put the programming track together and so forth. And if anything else happened, if you had to reset the board, typically you have to take the whole thing apart. Well, now what we have is on all of the boards, there's a solid state magnetic sensor, no moving parts. And so when you use this little refrigerator magnet, just wave it over the end of the car, then the board will reset and back to the default address 3 and the standard brightness. So that works really well. And let's turn this on. Let's switch to Loco 3. And this is instant on and instant off, and then you can see that it can fade and we can adjust the brightness. So there you go. So let me show you the other thing. Here's an N-scale example of the floating brass on N-scale. You see it's very small. We tend to like to put the wire, I'm going to use this as a pointer, right here through the base of the wire. So that keeps it out of the way of the coupler. And a couple of people have asked me, can you put it inside, drill a hole through here? We don't recommend that for two reasons. You can see that you can't see the wire here because it's going up into the body. So there's no wire hanging down and running the potential of catching something on the track. So what the wire does goes through here and right inside the body and up through the body of the car. And you can see that in this example. Another feature, having done a lot of installs, is at the beginning, both the DCC connections were at one end of the board. Well, that's great for Kato because the pickups are at one end. However, in this car where we're going to use our floating brass, what we wanted to do is just have a contact at the other end. So the wires can be neatly tucked in and they don't have to run through the car. So a lot of little subtleties that we learned, customer experience and our own experience installing the light boards. Okay. So let's see. So now, let's take this off the track and just get it out of the way over here. So that's a standard board. We have, like I said, the two sizes. I'm going to take these off the track. And what we did then is went and designed a caboose board. And of course, the caboose has no pickups, and they never have pickups. So we used our floating brass and put that in. And the first board that we made, this is actually one of the samples, it worked okay, but because the car is so light, particularly in N scale, and it was not designed for the pickups, it was intermittent. The light was intermittent. It just didn't stay on long enough. So we fiddled with that a little bit. We redesigned the board, and we added a special, what we call super cap board. And these can be piggybacked underneath the main caboose board. In fact, you could have more than one if you like. And that really does an incredible job of keeping the lights on. So that works out fantastically well. And I'm going to show you how well by putting this car on the track. And let's see, get the right loco here going. Oh, don't have it on the wheels. There we go. There we go. Okay. So you can see, oops, I just bounced it off the track. There we go. All right. So what I'm going to do is pick up one end of the car here, and you're going to see, get that right there. There we go. Let me see, get rid of that. Okay, so we got okay, there we go. So when I pick up the wheels off the car, the lights stay on for 3 or 4 seconds. I'm going to pick it all the way up, put it back down on the track, pick it up. So you can see if it was going over a frog, it'd do a great job, and pulled behind a freight train, terrific. So this is, interestingly enough, nobody had put together a combination of parts to light cabooses. So we have an N scale and HO caboose kit. And no caboose would be complete without a lantern. Well, we couldn't find lanterns that we could just resell. And as we'll talk about a little bit later, we got into the 3D business. So now we have an HO size lantern. You can get warm white or red for the LED. And there's a little tiny LED that we put in there, and we use some more of our gallery glass. And that can be fastened on and attached to the auxiliary pads on the caboose board. Now that's the HO one. For N scale, we had to do something different. Here is the N scale. Actually, let me show you the car here. So here's the carcass that goes on here. You can see right at the end, at the back, there's a lantern. And inside the car, we have a fiber optic cable. It's about an inch, a little over an inch long, and a dongle, which has the LED inside of it. So that bit looks like this, and I have this connected up to one of our controllers just so you can see it, and you can see that the red light, I can turn it on and off there, and that just goes right inside the N scale caboose. So pretty cool. All right, so that's the caboose side of things, and now we'll go into one more thing on the HO. So here are the two HO boards. This is a double row board. Oh, I didn't mention on N scale. So almost all the light boards have a center row of LEDs, whether you're battery powered or some other kind. And most of our boards that we sell, the center ones are just fine. But for the sleepers, there's a hallway, and then there's the rooms for the cars and the sleepers. And so we have a dual row board available in N scale. But we also have it in HO. Now, what we found is that from customer feedback, customers saw this double row board and said, well, that's great. I can use that and hook that up to my DCC system, and I can use that to light my backdrops and my scenery. So can you give me some different ways to connect this up, not just DCC? So this board has a number of different features. We didn't need to put all the capacitors on because we're not going to put it on the track. There's a little push button here, and if I push it once, the light will come on, and we can push this again to adjust the brightness. There's no mechanical switch here, so this is all done by the circuitry and the push button. And when I get it to what I want, I just push once and it will blink, and that will save the setting. You can also turn on the rear LED light, and you can have that blink as well. So that will means that the board will work on DC as well as DCC, and of course all of the other boards will as well. The last thing that we have in the works for product release over the next 60 days is a remote control infrared sensor on here where you can remote control this. So one of the things we found is that when people are operating their trains, they might have 2 trains running, to then try to switch back and forth to turn the cabin lights on the cars got to be a little problematic. They said, look, I'm just going to turn it on and off occasionally. Can you give me a non-DCC way to do that? So that's definitely coming. And then if any of you have spent time on our website, you may have noticed that we have quite a number of dome cars, both in HO and N scale. And so this is the only board we make which does not have a decoder on it. It just has a series of LEDs. And this can be cut at different lengths. There's connectors on either end. These wires can be connected to the main boards and turned on and off in parallel with the mains, or it can be connected with the auxiliary and turned off separately. So we do that on the dome board where there's not an end of car red light. We'll use the same circuit to turn on and off the dome lights. And this could be 2 or 3 lights, or it could be the whole dome board. We also found a couple of customers said, well, this is great. This is inexpensive. I like the way this is set up, and I can fasten this inside my buildings to provide lighting. And we're going to talk about building lighting in the next section. But this is a dual purpose, both for dome car lighting and for building lighting. So we have a very complete selection of lighting boards. I mentioned all in different colors, different capacitor types. And with the floating brass, there's no reason not to light your cars. In this section of the video, we're going to talk about building lighting. As we talked about last time, we had the passenger car lighting, and we developed a circuit board for that and a decoder. Well, in this case, what we did is I'm an N-scaler, and this is where we started, so I built a board that has 16 circuits, not just the 2, and works quite simply. It also has the DCC decoder on it, and we just give it power, and we were going to select the loco and enter. Let's see, loco 3, enter. And there you go. And so we can control and set animations, and we started building all sorts of animations. We have flicker, blink, Mars lighting, fading in and out, random. And so we're going to talk about those things today. But anyway, this is the first LED controller board that we built, and I designed this specifically, I'm going to unplug it, to fit inside my N-scale building. So I'm going to open this up in a second, but this is sitting in the roof. And right now we have this on animation mode, and I've set almost all the pins to random. You can see this one blinking every once in a while. This building over here is kind of cool because it's the smallest N-scale model building. This is actually a pre-built one from Woodland Scenic. And what they do is they have one LED inside in the roof, and then they darken all the windows. So the first thing that I did was just gutted the inside of the building and put some frosted glass. Pretty simple, just taking all of that out. And then what we have here, I'm going to turn this around so you can see that the controller board is actually in the back of this styrene room carcass, if you will. So it's pretty simple. Just cut some styrene, glue it together with super glue, and on the room light, on the building lights, like this yellow entrance light here, we used that same technique. We used a warm white bulb and kept dipping it in clear gallery glass, dries crystal clear, and then the last coat or two, we used pumpkin. And it turns out that pumpkin produces the best orange for our purposes here. And the beauty of this is, and that'll just slide on right there, is that underneath all of this, there's only 2 wires coming out to my layout. So in the building, there are 2 wires going down, and that's pretty easy to connect. This upper right-hand window here, you might see it flickering in different colors of red, green, and blue. We use a RGB red, green, blue LED connected to the circuit board, and it simulates a TV. So that's pretty cool, and you can do that. It doesn't take much. This can be programmed with your DCC system. I'm going to take this one apart so you can see how this one's made as well. It's a little bit trickier to get this guy off just because of the styrene and everything connected. But there you can see the circuit board on top. And this can be powered from DCC. You can create a zone specifically for your animation and lighting if you'd like. Or on all of the boards, there is an extra set of pads, connectors, that you can run a 12-volt supply so that you're taking up only the DCC signal, but supplying the lights to the building is coming from another source. So that's a lot of flexibility in that. And this is one of my favorite buildings. And I'm going to just turn it around like this. You can see we've also used a gallery glass dipped 0402 light in there. And then we just used a red LED on top. Okay, so you just put that down. And that's pretty cool. There you can see the 2 wires coming out from under the building. All right, so that was the microboard is what we call that. Then we started thinking, all right, well, so if we're going to connect Woodland Scenic and other product, what else is out there that we can use? And we looked at the hub system, we looked at all of the different capabilities, and we weren't really satisfied. So we built the first, specifically for trains, this is called the LED scene controller, now lighting scene controller. Uses another power supply here. All the plugs are plug compatible with Woodland Scenic. But we didn't like paying $4 a light. These are Woodland Scenic lights here. This is one of our little junction boxes. These are about $4.50 even on Amazon or eBay. It's pretty expensive. So we wanted to have people light their buildings and do a lot of it. So we manufacture our own, what we call these LED chips. We have these assembled for us here in Orlando, Florida, including the connector. And this is plug compatible completely with Woodland Scenic. There's no resistor on this, so you don't have to worry about it. We've built all the electronics and all the resistor, power supply, different voltages can all be supplied and controlled by the scene controller. Now this is our demo unit for our dealers, and we just took a Woodland Scenic's flat kit, painted them up, I put a magnet in so these will stay intact. And we have 2 different kinds of lighting here. You'll notice this shine through, we have a frosted glass type. When you do that, I recommend you put the light directly in the back of the back wall so it shines out through the frosted glass properly. Here I just took, I went to Google Images and cut up some cardstock and folded it and put that inside. Now you might, in the last demo I did, I made this blinking. This should have all been random. So let's change, I'll show you how simple it is to change the special effect on any one of the ports. So here's our controller. Right now, without the display on, it's in animation mode, and that's just the running mode, if you will. So I push this button and hold it, and now it shows port 1 on the left side and the animation effect on the right side. There are 99 special effects. Plus, you can also use CVs to fine-tune this. There's over 5 million capabilities, 5 million settings that each individual controller can be set to. So what we do is we push the up and down buttons to move to the LED port that we want to control, okay? And this is the one that was blinking. So let's change it to Mars, Mars effect. So that's a sort of fading up flash and fading down. And right now you see port 4 is set to 3. I know 3 is blinking. So if I push this to 4, I know that's the Mars effect. And I save that, and then I push it back into animation mode, and just watch what happens over here. It's as simple as that to program all of the different effects for the ports. Now there's 16 ports on the controller. It also has a full DCC control decoder in it, and it can be set to behave as a multifunction decoder or an accessory switch. So each one of these ports can be operated by a switch, and you can have multiple controllers overlapping switch numbers or in parallel. It doesn't matter. We have the connectors that I mentioned before, so you can connect 64 LEDs up to a single controller. The controller has a 1 amp capacity. Each port has 100 milliamp capacity. So you couldn't fill all the ports with 100 milliamps because that would be 1.6 amps. But that's more than enough. We ran a demonstration test case, hooked up 64 LEDs just like this, plugged it in, and running at 50% power just worked great. Again, each port can operate and be set to a different special effect. And if you were to buy all these special effects, whether it's flashing police cars, alternate flashing, marquees, welding effect, lightning effect, if you were to buy 8 or 10 of those, you've already paid for the unit. So this is a much better way to go. You can put this near your control system and then run the wires out as you need to the layout. Or there's various versions of this. Here's another version which doesn't have the keypad, but this works like the board I showed you earlier, and it's fully programmable via your DCC system, and this could fit right inside the building. So lots of options in terms of the configuration there. All right, so let's bring up another demonstration here. Okay, same type of controller, and this is an HO Sales building. These are two lights that I got off of eBay. They can be controlled. Here's the Woodland Scenics police car that I took apart. I added some more LEDs and connected that up, and so they can be controlled separately. And here is just the hotel. You've probably seen this before. And in this case, I used the roomettes. They're cardboard cutouts for the rooms, and just glued the LED right on top, and then just ran the wires out back. Here's a couple of our junction connectors, and that's the way that worked. And like I said, here's the controller, and this will fit right inside. If you want to have all of the wires inside the building, and then just have the 2 wires coming out to control DCC. All right. So let's show you another controller we have here. All right, so this by the way, we started making our cases in the United States. We 3D print everything, which is truly amazing. And so now we can make cases. And as we change the product design, we just changed the design in the software and start printing a new one. Here's a test board that we use for configuring and testing. You can buy this on the website when you buy the controller. And this just plugs into the back. And we have other sizes. In fact, here's the terminal block. And this will fit inside the Woodland Scenics. The spacing of the connectors is the same. Theirs is actually a 4-block hub. So there's a version of this which has 4 blocks, and you can connect that up. All right, so let's plug this in and turn it on. I'm going to try to do this upside down. So 111 means this is in the multifunction mode. If it was 2222, it would be in switch mode. And you can see now you can combine effects working the special effects across ports. So this is what I call the race. And then there's another one that's chase, so it just goes one way and one way, like the landing lights. And here's one where we're going to use the CV's programming ability on the controller without we're not connected to DCC, but we keep consistent with the DCC system, and we're going to change the rate of speed of that special effect. So I've moved it into configuration mode, and again, you see port 1 here, and I can just go up and through the ports, okay? But we're going to do something that affects all of the ports. So I'm going to go and hold these bottom 2 buttons for a couple of seconds, and it'll flip into CV mode. So C stands for CV mode, and it's at 208. This is typically the one that's used for triggers, but what we're going to do is we want CV 122. So we can go up or down, doesn't matter. We're going to get ourselves to 122. Okay, and I'm going to push this once. That shows me the value is 3. So that's pretty fast for the display here. I want to increase that number to, let's say, 12. So the higher the number, the more time it takes to get from one pin to the other. The yellow is the save button, and then we're just going to put it back into animation mode, and you can see that it's going to go much slower. Okay, so there are lots and lots of special effects that are available on the device. You can have a lot of fun with that DCC connection, and there you go. All right, so that's been pretty much the first year. In the middle of the summer last year, we started working with fiber optics. I've been doing fiber optic projects for a long time, and the first thing we did was make a fiber optic controller that used all the 16 channels with the LEDs inside the box. And you can see now, you can see all the lighting. Each one of these is individually controllable, all the same animations that we just talked about. I have a 3mm fiber put in here, or you can use our pin system, and we're going to demonstrate that in a minute. We have special pins that go in for different size fibers. So if you have a 0.75mm fiber, that'll work 1.0 and 1.5mm. All 3 of those will work comfortably in this system. One thing, all of the controllers, this is a dummy unit, have a magnetic base plate and a magnetic on here. So you can use double stick tape if you like, or just slide it in. The magnet's not in the way. But if you get the bracket, you can mount the bracket upside down on the side or whatever, and it's strong enough to hold the unit in place, and you just pop it apart. So that's really cool. All right, so in concert with a company called Dwarven, this is our controller, we've invented a fiber version. This has fewer special effects. It really only has 3. It's on for a port, it has blinking or alternate flashing. So alternate flashing would be something like a crossing gate, the light that alternate flashes back and forth, and you can see that we have each of the ports. Now you'll notice there are 2 lights on for each number. So there are 8 ports with 16 holes. So there's 2 together. So if you were going to do a flashing signal, you'd have 2 opposite or adjacent sets of 2, and you'd run the port out to your crossing gate. Now what we're going to do is demonstrate another method or another application. Here's a cast model car, and we drilled the headlights out and just put in, inserted some fiber optic, clipped it, and now here you can see the pins that we were just talking about, and they're at the end, and so we're just going to insert them into the 2 connectors, pin port 1 and port 2, and I'm just going to cycle back and forth between them. So special effects like that. So that's pretty cool. But wait, there's more. So what we want to do is we want to trigger those lights to come on. So as part of our release in 2021, this year, we have a series of detectors. This is a magnetic detector, and it's the same magnetic detector we used in the light board. No moving parts, so no reed switches or anything like that. We designed the fiber controller to have a power supply. Untwist this a little bit. So the power supply to run the detector. So that's on this side over here. And I'm going to turn the power off, get that going. And on this side, we have 8 detecting circuits. All right, so there's a lot you can do with this. And here's the application of the terminal block, the 4-point block. And I'm going to turn this on. Okay, and so we have nothing on here. I'm going to roll this across, and you can see I've set this to alternate flash, triggered by this magnetic detector, and it has a timeout of 5 seconds. So you can change the timeout, and you can speed up or slow down the flashing. So you could have the flashing going on for 10 or 15, 20 seconds, however you like, all controlled by the fiber lighting controller. And did I mention this also has a DCC decoder in it, like everything else? And so to wrap this up, wanted to share with you our newest product. This just came out and will be available in about a week's time. And what this is block signal controlled. Oops, let's cut these backwards. Let me do this. So using the same detector, we will also have infrared detection under track like this. So this is magnetic, we'll have infrared, and we will also have a version that's on the side of the car. So you don't have to dig under the track, you can just put it next to it. Now, when the car goes and triggers the light, you'll see that the light changed from green to red, and there's a timeout period, and then it will change back to green. And you can adjust that time period. So how simple is it to connect our block signal? Here's the block signal. I ran a hole through the layout. Here's 2 fibers. These come in 10-foot lengths, so you can just run it out to the controller, literally just plug it in like that, go to the other side, plug it in like that. What did I do? Oh, this came loose. There we go. In February, so this is a red and green. So this is a really simple one. We will have a dwarf version of this. And then in February, we will have a unit, a controller that's about the size of this box. It will go under the layout. It will have holes for the fiber optics, and in that case there will be red, yellow, and green. And all you do is you put that under the layout, connect your detector and power, and run the 3 fiber optics, red, green, and yellow, into the box, and you have a fiber controlled block signal. Thank you very much. That's it. Now we be happy to take questions and answer any curiosities that you have, and thanks for watching.